Hello, this is the Tepid Coder. Today I want to talk about the order in which things are constructed and deconstructed in a class. So I'm going to make a kind of contrived example today. But it came up in a video where I was kind of explaining something, and the order that I needed to free some resources mattered. And I kind of did a brief overview of it there, but I think it'd be good to have a standalone video. That's why I'm doing this. So I'm going to make basically code that shows the order in which things are being constructed and destructed and explain what's going to happen and then show it happening. So I'll make a class called first. Let's see, first constructor. Right, we're gonna have a, come on, first destructed. Still getting used to this keyboard, man. Private, and then we'll have some public. I'm not actually putting anything in private right now. First. Okay, there's my constructor. Give it a body. Okay. Let's do the same thing for the destructor. Inside of here, I want to do standard cout. I'm going to do pretty function. So whatever the name of the function is, was called. Standard on. Standard line. Okay. Paste that here. Okay, so it'll let me know that this was called, or the destructor was called, right? And I'm going to do the same thing here, but I'm going to make some more classes. So I'm going to have, let's see, first, I'm going to have one I call second. Let's do this. I'm going to search for and replace first with second. Yes. Okay, and then done. Now over here, we're going to say replace first with, I'm going to make a class called assign me. It'll make sense. Oh, really? Okay, try that again. Searching for first, replacing it with assign me. And finally, I want to have a class that I call parent, let's say. Okay. So now in this parent class, what I want to do is I want to have some members. I'm going to have one called first. Okay. I have one called second. I have one called assign me. In this one, I'm going to make an operator overload that accepts integers. I'm going to say it equals 1 here. Okay, so let's make that real quick. I'm going to say assign me rather, operator equals. And this operator is going to take a constant integer reference. And say RHS for right hand side. Now, something interesting that I kind of forgot about before when I mentioned my first, what do I say? There was another video where I talked about taking like a copy constructor or something that used a constant reference, and the compiler complained at me because I was trying to do both a constant and also one that took, if I do this again, just like a just a standard int or standard like, constant like this. If something is taking a constant reference, you're allowed to put a temporary value in there. So it treats those in kind of a special case. Even though if you pass a temporary variable in here, you can't really reference a temporary, it still accepts it. I think it just generates the proper function for you. Anyway, what I'm going to do inside of here is essentially the same thing as this, but I'm going to say it was called with value. I'm going to say, oops, RHS. So let's do this, break it down to a line so I can read everything. Okay, so that's going to get called. Now keep in mind right here, this is going to call the copy constructor because I'm both defining the variable here and assigning it at the same time. That calls the copy constructor. So I'm also going to have to make one of those. I'm going to say assign me. It's going to be called assign me. It's going to return assign me reference. You can chain it. Assign. Actually, I don't want to do assign me. I want to do copy constructor with constant RHS. And it's just going to call operator equals with that right-hand side value. So this function, when you do the copy constructor, it's going to copy from that type, using the specific overload right here. It's going to call this function right here. So they're going to do the same thing. What I'm going to do here, just to make that clear, is I'm going to say, print out this was called, right? It's going to say assign me was called. Okay, so now what I want to do is I want to make some enhancements to my default constructor for my parent class. And here I want to say m first gets assigned to its default constructor. I want to say m second gets assigned to its default constructor. M assign me is going to have its what do I say? Its special constructor takes an integer assigned to, let's say, 2 this time. Now, because I made this is no longer going to be called. These are both going to call the default constructors. And by the way, using these curly braces is something I can do if I want to specifically call a constructor of a class that takes an initializer list. I haven't showed that yet, but I'm going to show that in another video pretty soon. If there's no initialized list, it's going to be the same thing as doing this, right? Anyway, I'll show that. I need to make a function entry point now. Let's do that real quick. Return 0, show there's no error to OS. I'm going to construct a parent class, call it P. Let's just look at what happens real quick. So, g++ test.cp out test. So what did I mess up here? Okay, we have 9. Return type specification for constructor is invalid. Assign me. Okay. Oh, because oops. Yeah, I copied that assignment operator overload, which needs to return something. I meant to put assign me reference here, and this one is actually a copy constructor. It needs not to have any kind of return type. And I need to actually define these somewhere too, so why don't I do that now? I forgot to actually make these. Okay. Yeah, so this will be the copy constructor. Okay, and then I'm going to say the operator equal, yeah, okay. Don't need to see what class it comes from because I'm in it. Okay, I don't really need to name that there, although I can, it's fine. Okay, member function, assign me. This is the operator overload. No return statement, right, I need to actually return from the operator overload. So, return this. Now remember, this refers to assign me, in this case, reference, like that. And what I'm doing by putting the asterisk in front of it is I'm dereferencing it, and I'm getting just assign me. But then we're returning a reference to it over here, so it becomes this, right? It becomes referenced. That's what's happening there. Okay. And we're going to do compile here, test. All right. So now what you can see here is before our constructor gets called for the parent class, it's actually constructing its members first, one at a time. So first gets called, then second, and then we have assign me, and this is the constructor that takes a constant int reference. And we're able to pass our values in there, which is a temporary value. And then after that, it's going to call the version that is, what do I say? It's going to call the assignment operator overload, because that's being called from this function. Okay, and then finally, everything has been constructed. The parent can now construct. So that's what happens. Okay, and then the parent goes out of scope, it gets destructed. The parent constructor gets called first. And then we have assign me, which was the last member we defined, then the second member defined, then the first. So you can see what actually happens in here is we construct in the parent class. First, we do our first member, second member, third member, all our members basically, and then our constructor gets called. After that, we're going to be in our body here. So you can see right here, we're telling it how to construct these objects though. We're saying to construct this with its default constructor, we're saying to construct this one with its default constructor, and we're saying to construct this one with a constructor that takes an integer. And after all that's done, these are all in a valid state, and this gets kicked off, right? And we're in this constructor code. When we destruct, the opposite happens. Our constructor gets called, or our destructor gets called first, and then it starts calling destructors of all of our members after our destructor ends in reverse order. So this one, this one, this one. So let's take a look at that again. Okay, so first, second, and we have the constructor that takes this integer, yeah. So this isn't even being called right here. This one is. So what I want to show here, did I even show that? Yeah, call with the value 2. So that is being shown. I'm going to get rid of the, what do I say, the construction inside of the initializer list. I'm going to recompile it and show you that it's going to be 1 now. Right, now it's value 1. So if you have anything assigned over here with a default value, that's going to be superseded if you put it into initializer list and construct it there. But it's still useful to default things here, just in case you add a new member and you forget to, what do I say, initialize the value in one of your mini constructors, because you might have 20 constructors in your class or something crazy. So yeah, so that's really what I wanted to show in this video, just the order in which things are constructed. And I think that's probably about it. I think I want to show one extra thing actually. That class assign me, I'll say am equals 2 here. Compile that. So you can see here, it's calling the copy constructor, which is specialized for this constant int reference type. And then that is calling the operator overload for a constant integer type and just forwarding the value to it. Now, what I want to show is, if I don't take this by constant reference, right, let's not do that, and I change the definition in the class as well, it's going to complain, because you can't put a temporary value. You can't reference a temporary value. I'm saying this is a reference to something, right? So let's try that. Compile it. And when I try to compile, it says cannot bind non-const, see, non-const value, L value reference. L value means it's not a temporary. So essentially L value, I like to think is like a long-lived value, right? Let's say I have some type here, like int I, right? If I pass this to a function foo, the foo function can actually reference this. If it takes like an int reference like this, it can reference this variable because this has a memory address. But if I pass it the number 10 or something, you can't reference the number 10. It's not a variable. So if it takes a reference and it wants to update it, saying like, I equals something, like 1 inside the function, that will work if I'm passing an actual variable. But if I'm passing the number 10, you can't really say 10 equals something, right? It's just a number. So anyway, I'm going to put that back in, because I've been putting this code on my GitHub branch for everyone to play around with if they want to. I want to make sure it's in a functional state when people play with it. Alright, also inside of the class definition, I need to make it const again. So, okay, const. And that error would have said, like, there's no definition for that kind of method in the class. Okay, so yeah, and I'll put this back in here. Okay, and that 2 being crunched up against value here is kind of annoying me, so I'm going to space that out. Let's finally fix that. Okay, and you can see it all working. Anyway, this would be a good thing to review if you're ever confused about the order in which things are constructed, and whether a certain constructor is even being called, as with the case of the parent class, assigning something here. This isn't being called because, well, it is right now, but because the initializer list defaults it to something. Okay, I think that's about going to do it. If you have any comments or suggestions or questions, suggestions for follow-up or whatever, please do leave those, post them. And if this is content you like, maybe subscribe. And I will catch you guys later. Have a nice day.